Beamer ins Gesicht schreiben. Oh. Okay, Ton. Ready to start. So, welcome everybody to our talk. It's actually not that much about Java, our talk. It's more about the fun stuff you can do with Java. So, before we start with that, I'd like to ask all of you, who's actually doing home automation already? Okay, quite a few. Who's doing home automation professionally? Okay, hardly anybody. Nobody, I would say, even. Okay, who would call himself a Java expert professional? Okay, most of you. So everybody who didn't raise their hand on the question before, you should be sitting next door somewhere at JDK 8 stuff and so on. I hope your bosses do not know that you're actually just visiting the fun parts of the conference here. So let me introduce myself. My name is Kai Kreutzer. I'm Java and OSGi developer since many years, software architect, working for Deutsche Telekom. And I'm really a home automation enthusiast since my childhood, I would say. So I had already my Commodore 64 playing music when my parents entered the room. And I built my first switchable socket at the age of 12 and did a lot of hardware experiments there. And so it was quite natural that when I built my own house 4 years ago, that my central switchboard had to look like that. So it had to cover a full wall in the room. And after doing all this hardware stuff, I noticed it's not really just about hardware. A major piece is really the software for it. And there wasn't anything good around at that time for me. And so I started building my own software, created a project doing Java as I was used to that in my job. And I thought, well, it's quite a lot of work to do, so let's directly share it, make it open source, and let's see if there are other guys who might be interested in it and might think it's useful. And one of these guys I found directly during the first year, and he should introduce himself now.
Yes, my name is Thomas Eichstätt-Engelen. I'm a Java professional as well. I'm working for InnoQ Deutschland, which is a German-based, medium-sized software consulting company. I'm home automation enthusiast as well, although my switchboard looks more like that, so no real picture of it here. I'm openHAB committer, as Kai said, since the end of 2010. And yes, recently my wife called me kind of a home automation geek with respect of the level of automation we've already reached at home. And in preparation of this talk, as we looked around, we find more home automation geeks out there. Look what we find on YouTube.
Okay. The X10s are online.
A bit louder.
Gentlemen, I am now about to send a signal from this laptop through our local ISP, racing down fiber optic cable at the speed of light to San Francisco, bouncing off a satellite in geosynchronous orbit to Lisbon, Portugal, where the data packets will be handed off to submerged transatlantic cables terminating in Halifax, Nova Scotia, and transferred across the continent via microwave relays back to our ISP and the X10 receiver attached to this lamp.
Look at me, I've got goosebumps.
Are we ready on the stereo?
Go for stereo.
Hey guys!
Hello.
It's a little loud.
No problem. Turning it down. San Francisco, Lisbon, Halifax.
Okay, thanks.
Hang on. Do you not realize what we just did?
Yeah, you turn your stereo down with your laptop.
No, we turned our stereo down by sending a signal around the world via the internet.
Oh. You know you can just get one of those universal remotes at Radio Shack. They're really cheap.
No, you don't get it. Howard, enable public access.
Public access enabled.
Boy, that's terrific, but I'll see ya.
No, hang on. See?
Someone in Sichuan province, China, is using his computer to turn our lights on and off.
Well, that's handy. Here's a question. Why?
Because we can.
Yes, because we can. It's really a bit like that. Women are sometimes so unemotional. Yeah. But okay. Let's do a short. We try to in the remainder of this talk, we try to provide you with some winning arguments to convince your partner ordering a home automation system right away. So let's start with a short theoretical introduction, and let's define what our understanding of home automation is. For us, the key aspects of home automation are automation and integration. And I would like to emphasize on the integration aspect. Home automation is not just electrifying things, because that's what we already have at home. We have blinds that are going electrically down, up and down and are timer controlled, or there are remote plugs or sockets with these ugly remote controls lying over there. And we have many, many apps on our smartphone controlling the TV, the stereo, and the Christmas tree. But the point is, none of these systems are integrated in any respect. And that's what home automation is about. Home automation ties up and integrates all these different components to each other and provides higher level functionality on top of it. Higher level functionality like persistence, like rules, like visualization. There are three goals that home automation tries to achieve. The comfort goal. Home automation, or smart homes should be able to behave intelligently and independently in accordance to different situations. They should switch off the light when nobody is at home, or they switch on the air conditioning if it's too warm inside, or they level or decrease the volume level if there are incoming calls. Security. If you already achieved that comfort goal, there are already a number of sensors in place. Why not reuse them to gain the level of security in your home? There are motion sensors. There are window contacts. Why not reuse them? And the third goal is energy saving. Again, there are a number of sensors in place, temperature sensors and so on. Why not reuse them to gather consumption data and provide some kind of energy awareness? The main aspect is, or the main goal of home automation is to create smart homes. And to create a smart home, you need smart devices like that. You have all the different components, all the different crafts of your home at your fingertip. It's the same usability. If you control blinds or the stereo, it's the same. And if you're not at home, use your smart device. Control it the same way, and yes, use it from all over the world. Or if you are going to visualize data, what consumption data already active, then yes, visualize them on your tablet. Many, many of these aspects are already implemented in openHAB.
Okay, but before we come to the fun part, which will be the live demo, you have to get through a few slides just to understand the concepts about the thing. So, as mentioned, the project openHAB, it stands for the Open Home Automation Bus. It's the code that I started in 2010, made it directly available on Google Code under the GPL v3. We have also a nice, smooth build, very easy IDE setup. So for everybody who wants to involve himself there. It's quite easy to get into that. With the continuous integration server, we even have nightly binary builds of all the latest sources available. This summer we released version 1.0 and yeah, already had quite a decent number of downloads on that one. So why are we here at the Java conference at all with that topic? Well, as I mentioned, it's built in Java, but it quite uses some interesting frameworks and technologies, which makes it interesting for every developer as well. So the main part, as Thomas said, is really the integration of things and putting automation rules and user interfaces or visualization on top of that. And for this, we have the openHAB runtime, which is a headless Java application running on small devices like a Raspberry Pi, already up to any server, wherever you like. So all you need is more or less a JVM. We provide another piece of software, which we call the openHAB Designer. And the Designer is more or less a desktop application to do remote configuration of your system with nice editors and so on. So every configuration is text-based, so you can also use VI on the command line directly on your system if you prefer that. But for all others, the Designer is quite a useful tool. So how do they communicate with each other? Well, the simplest way is to really just have a Samba share on your runtime and access that. But there's also a nice feature, which is a Dropbox integration. So you can actually synchronize your configuration files to a Dropbox folder and change your configuration from anywhere in the world where you have your Dropbox configured. Same for log files, so you can directly automatically synchronize the log files to there and access them from anywhere you like, even if you're once offline then. Technology stack on the runtime side, it's Java SE underneath, built then very modular with OSGi, using internally a lot of OSGi declarative services to do all the binding together. All the configurations are done using models, the Eclipse modeling framework inside here. And every communication with the web, for this there's an embedded Jetty server. And for things like WebSocket, REST API, we use JAX-RS and the Atmosphere framework. On the Designer side, this is actually an Eclipse RCP application, of course using EMF as well, and these configuration models are built as domain-specific languages, using the Xtext framework, which is really a very, very good tool if you want to design your own domain-specific languages here, as it brings you very nice IDE support editors for that. And that was really a main goal for this Designer, to make it easy to see directly if your syntax is wrong, if you did something wrong there, you have auto-completion, and not only notice it when it runs on your runtime and your house suddenly behaves not as you would expect it. Besides Xtext, we also use Xbase, which is more an expression language or even scripting language that you can easily embed into your DSLs. So for things like automation rules, we make use of that. Now let me briefly talk about the core concepts of openHAB. So actually one of the main notions that you come across there is an item. So an item is something very abstract, and the name is meant to not tell you anything really. And we're talking about items, and say every item has a state, a status, and these are the pieces of data or of information which you want to control more or less. And for example here, a light bulb. What can you do with such an item? Well, you can actively send commands to it. You can tell this thing to be on or off, to dim to X%, to increase or decrease the dim level, and so on. On the other hand, something more passive, so nothing actively happens are status updates. You can say, well, you actually know that this real light has just dimmed to 50%, so you can send a status update to this item to say, well, your status now is 50%, please correct yourself. So these are really the main words. You might now ask, why are we talking about items and not about something, or well, like devices, for example, as many people do in the home automation area. But an item is something smaller usually than a device. And as an example, we could imagine that we look at a radio. A radio we could actually split down in different items. We could have one switch item to turn radio on and off. We could have a dimmer item, just like the lamp, for adjusting the volume. And we could have a number item to select the currently playing radio station. So the idea is really that we have basic building blocks in form of these items with which you can describe the whole world around you and every device that you might come across and every device that might hit the market sooner or later. So there are many new things coming up, and by these building blocks it's quite easy to support new kinds of things that nobody thought before. Now, the architecture of the runtime. The main thing is an event bus. It's a simple publish-subscribe mechanism on which you simply now send commands and status updates for these items. Just having the event bus is not really good, so what publishes and subscribes on it are so-called bindings. And these bindings are really now the link to the physical world, so to your concrete devices and hardware. And for each kind of protocol, for each kind of system and thing you want to interact with, you can have a dedicated binding then. And these bindings more or less simply translate between the abstract commands and status updates for these items and the real devices. With this setup, you already have achieved more or less the integration aspect. So you have your different systems being able to communicate with each other already. Now for the higher level functions, we talk about the virtual level. Actually, everything above the event bus is really now completely decoupled from the hardware side, so it's really just virtual level. Talking about items in an abstract way, and for keeping the state of the latest state of every item, we have the so-called item registry, which allows you to then build user interfaces and automation rules on that. Because on user interface, you want to see what's the current status of things, and automation rules have to react in a certain situation of your overall system. So you need that there. On the other hand, we also have concepts like consoles, where you can, in a textual manner, control your things. So you can send commands directly to this event bus. You can ask for the current status of an item in the registry, and do things like that. You can do it directly on the OSGi console, for example, or through XMPP Java integration as a remote console. The persistence support helps you to write things that are on the event bus to some storage. So to store it in database, to send it somewhere out, and just to keep track of things and not lose information there that you might have been interested in. Simplest use case would be logging, for example, on that part. Now, a brief overview of features. So the user interfaces that currently exist are here two web user interfaces. The left one we call the classic UI, which is quite simple HTML with CSS, mimicking an iOS application, and works quite well on most mobile browsers. The right one is HTML5 one using Sencha Touch framework, and optimized for tablet, so you have another navigation bar and so on. But besides the web UIs, we also have native user interfaces for Android, for iOS, and a very early prototype for Windows Phone as well. And well, the more interesting part for most of you might now be what kind of bindings do we actually have, and for this I hand over to the binding expert, Thomas.
Yes. As Kai mentioned, the main concept of connecting hardware to the openHAB runtime is called binding. And as you see here, we provide quite a few of them already. And by the way, those bindings which are will be delivered with the upcoming 1.1 release, which is scheduled for, should we say it? 16th of December. Then we have the 1.1 release in place. But besides those bindings, there are some other features which are already also interesting. We have those consoles, we call that consoles, and Kai mentioned that already. We have openHAB ships with the XMPP console, an OSGi console, and for me the most interesting one, the Google Calendar console. With this calendar console, you can create new calendar items, or events, and can textually define commands that are being downloaded and executed by the openHAB runtime at a given point in time. So you can use your beloved interface to the Google Calendar and control and trigger things at home. Quite nice. And secondly, there are the persistent services Kai already mentioned. We have queryable services. These services are meant to export data out of the openHAB system. And as queryable services, there are the DB4O and the MySQL services in place, or will be in place with 1.1, the MySQL one. And there are bare exporting persistent services which are based on irrigation for J to show these nice graphs. And we connect some of these new IoT services, namely Sense and COSM, formerly known as PetShoop. But enough theory for the moment. Let's dig into the code and see how it feels to work with openHAB. No. As Kai mentioned, everything starts with binding, with an item. The item is the abstract thing to configure in openHAB. That's the openHAB designer, an Eclipse RCP application. And we brought quite a few hardware with us. And we are going to create items for all of these different hardware parts and reflect them into the item file. So let's start. Control space. There are content proposals. Let's start with a switch item for a lamp here. It's a Christmas lamp.
We're just missing the tree.
Yeah, it's left at home. Okay, switch. New item of type switch called has the ID light. Okay, and then we have this nice tool here, the Kubashi plant sensor. They claim to make everybody a perfect gardener. And that one provides some environmental data, which we are going to show here in openHAB as well. So we create a new item of type number. It's called ID temperature. And we give it a label. Temperature, and it's shown as a decimal value with the unit degrees Celsius, and another item, brightness, label.
So while Thomas is talking, this is actually a good example of such a device which you wouldn't have thought of that it could exist possibly, but you can really simply model it with these different values that it can offer you, and you simply declare it as different items for the one device, and you can work with that and integrate it, make use of it.
Quite. Okay. So we have the last one, soil moisture, with the unit %. And we have now a string item which will represent the some instruction that this device can send. Do something with your plants. It's a plants advisor. So,
and it looks as if it's time.
yeah, it's time to do it. Okay, and then we have this one here. This is a doorbell. It looks a demo doorbell, and let's create it as well. So, okay, then after saving the file, we can look into the runtime. The openHAB runtime frequently reloads the configuration files, and then we can firstly talk to our items here. Okay, let's start and ask what is the status of the temperature item. Temperature. Okay. The status is unknown. But it's really unknown. Okay, we will see. Next, we are going to update the temperature value. I must rewrite it. Update temperature to 20. Oh, it's already 28.6 degrees. Okay. And now let's see what the status is. Normally there should be an answer from openHAB. It's the demo effect. Status temperature. And we see nothing happens. Really nice. Okay. State updated to 28.6 degrees. Okay, that's quite. Oh.
Oh, no, that's the feedback. A bit delayed.
Okay, it's. Oh, there's the feedback. Okay, also everything is fine. The answer for the first status query was uninitialized, and the second one is updated successfully. Okay, perfect. But okay, communicating with your home automation runtime or with the openHAB runtime via XMPP is quite geeky, but the women acceptance factor is really, really low. So let's create a more nice way to communicate with openHAB. Therefore, we create a new sitemap. UIs are declaratively
declaratively declared?
No, that's not right. Okay, you know what I mean. We do declare them. And we have the concept of sitemaps here. And so we create a new sitemap, control space. There is already a template for it. A sitemap has to have a name. The name is Devox, how surprisingly. And the label is main menu. Now, everything starts with a frame. We create a new frame, and we add our items that we formerly added to the items file to our sitemap here. There is a control space, it's the content proposal. We have the things here. And let's add another frame here with the text items of our Kubachi plant sensor. Temperature, text item, brightness, text item, soil moisture. Okay, save, reload, and then we can simulate our smart device with this neat browser on the right side. Let's start it. And okay, there's the first version of our UI already available. The switch is already functioning. It's doing something. Light on, light off. Okay. So we see that night bulb here on the left side for the switch item, and there's no default icon for number items. So to make it more acceptable by the women, we add some, or by the partner, temperature. We add some icons here. There are openHAB ships with quite a few of them, but you can extend them if you want. Sun and grass. Save. Reload. Reload. Nice. Okay, now you would say quite nice, but some kind of unrealistic because there is no hardware connected. So we have to add hardware. And as I said before, hardware is connected to openHAB by bindings. And so let's start and add the binding here. Bindings are added in curly braces, and we have already quite a few of them in place. There is the exec binding. The exec binding executes commands on the command line. It's our Swiss Army knife. If nothing works, exec works. And what we do is now, if the status of switch, or if the light item receives a command with type on, then execute the command conr.-on.sh, and if it receives the off status, then execute.
Maybe I can meanwhile just show this Conner device. So this is a small gateway with an Ethernet connection and sending 433 megahertz just across the table to this plug here, which will then hopefully switch.
Okay, you know, local ISP,
Not via Portugal.
Lisbon, Halifax, and nothing happens. Why not? Okay. Did I rewrite or execute it? Okay. We go further. It will happen sometimes in the next few seconds. We will see. The network is very hard here. Very, very hard. So we add more hardware to our configuration. I talked about the plant sensor, and the plant sensor has its own binding available. And I copy it from here. This one, okay, because I don't have that sensor ID in mind. Oh. So, okay, Kobachi. And let's copy it to the other items. Watering instruction. Temperature, brightness, and soil moisture. Save. Water instruction. Now we will see. Loaded file. That looks better. And now it's going to reload the files or reload the information from the internet. We can start that manually by starting and stopping the Kobachi binding. And then we will have to wait some seconds to query the values again from the internet. Okay. What do we have more? We have
want our plant to be talking.
yes. We right. We have this this Kobayashi sensor I talked about, and their slogan is "Give your plants a voice." And that's what we're going to do now. We are going to give our plant a voice. And to do that, we have rules, or we create a rule, a new rule. And there's already a template in place, control space, new rule, called watering instruction. And we have to create a trigger when this rule is to be fired. And this rule shall be triggered or fired when there is when the watering commands, the watering item received beyond command. Okay, what shall happen then? Then we have to then openHAB should say what our plant needs. So we say what the state of the watering item is, and hopefully, but no.
Could you check the log? I think you last stopped the binding. Could you start it again?
Okay, that's right. Was the wrong sequence. Okay. To simulate that, while we are waiting, we can use the openHAB console to update that watering items on ourselves. Okay. Update openHAB watering. I need water. Please help. Okay.
Shall we have a try? So let's ask our plant how it feels.
On.
It feels on. Ooh, that's no good.
Watering state. Okay. It's the string item.
You missed the auto update off.
Oh, yeah, right. There's some, okay. I missed that. Okay, auto update.
The comma.
Auto update.
So actually this auto update feature is something that automatically after receiving a command sets the status of the thing to what the command was. So that works then quite well if you have devices that don't give active feedback themselves, which just have a command but which never say, okay, my status actually updated. So here in this case, as we send an on and we don't want the status to be updated to on, we have to explicitly take that out and disable it.
And that's what I missed.
Okay. You were asking for help, so you got it. Yeah. Okay, so let's try again. We have an NFC tag actually to our plant so that it knows.
I need water. Please help.
Okay.
Okay. Yes, the demo effect. Okay, I think these are my parts. And now I hand over to Kai, and he's going to show you some more sophisticated features of openHAB.
Actually, also some real-life use case, because what I brought here, and this is not my real doorbell from home, but it's a doorbell that I like to take with me to demos, because it really shows that you don't have to invest into a lot of hardware to do already some quite nice things around your home. So all you actually need is a €3 USB to serial converter cable and some courage to cut your cable at home that goes to your doorbell. And then you simply take the push button, shortcut 2 pins on the serial port, and attach the whole thing to your computer. So that's exactly what I did here. And so to bring our doorbell here to life, all we need is to tell it as well some binding information. And this is simply the information on which port, which USB port we have connected it. So Let's see right in here, if we press, okay, already works, gets updated. Now your partner will anyhow complain because it's not working as before. You will miss all your visitors. So let's get it at least in the status quo as it was before, so that everything's fine. For this, we simply create another rule, call it doorbell, and say also in state changes, our doorbell item changed to on. Then it could simply play a nice MP3 file, just like that. Okay, and hopefully now, if we press here, we won't miss our visitor anymore. Okay, but that wasn't yet the fun part, really. It's really as it used to be before. Maybe it sounds a little bit better, like a very big villa or something you live in. So the interesting thing now comes what you can do after reaching that. So it's nice that if you're at home, the doorbell rings, but while you're away, it doesn't make much sense. So let's improve this rule a little bit and make it smarter. So let me, for this first, add another item, which is really an item now which we just need for the logic. I call it presence. I save it here. We can add that to our sitemap as a switch. There it is. Okay, if we reload here, we see now we have here a presence switch and can do that. Let's improve our rule and say, well, if the presence state is on, so we're at home, then do what you did before. That's fine. But otherwise, you could, and then let's see how well the network works here. You could XMPP, okay, send us some information right away on our smartphone. I type in openHAB, my XMPP address here, and say, oh, somebody is at the door. Now, besides XMPP, we can also send an email, and with an email you also have then the possibility to add another parameter, which is a URL to your webcam that might point at the door, so you directly get a picture of who was there. And you're laughing. It's really, that's what I do at home. I have everyday pictures of big DHL delivery trucks in front of my door, which deliver all the stuff I buy on the internet to my wife.
Zalando.
No, not Zalando. Okay, so to show that actually to you very real, I just attach the webcam here and see if the network really works. So let's activate that picture. Do you see yourself? Okay, wonderful. So I'm at home. It rings. I'm not at home anymore. It doesn't ring. It makes it duck there. And now it's the delay. I heard some noise. There we go. Somebody's at the door. And actually, while we're here on the console, I could also show you now really the live case, the status of the watering. We ask, uninitialized again, okay, demo
Because
effect.
we reloaded
Okay,
the file.
but we don't show that, right, exactly, we reloaded the items file, so the status got lost, and the Kubachi binding isn't working out of some reason for the moment. Let's check our emails. Who was there? No messages. No messages. Still loading. Come on. You know, it works 50 times while you're preparing the talk, and then the network just gives up.
Give it a second.
Let's give it a second, or let's start mail right here. Ah, okay. So we see we were lucky that we weren't at home this time. Okay, now you might say, well, always switching this toggle here when you leave the house or not, it's not very smart, so you could improve that as well. So it's very simple to determine for your house when you're at home, because your smartphone is at home then, and your smartphone registers at the local LAN. So we just have to put in the IP address here. This binding we call network health, so it's actually for monitoring all devices on your network, so you can also do power on LAN on devices and things like that, and really see which devices are there, which are active, and so on. And now if we turn the presence off, it should actually automatically notice that my phone is also logged in here, and should automatically update that after a couple of seconds. Okay, actually the reload wasn't working. Okay, there we go. So it automatically switches then, and now notices when I'm there and when not. Just to show you some more features, what you could do with that is we could introduce another rule to have our house welcoming us back home. Well, let's call it a coming home rule, and when another state change, so when our presence changes to on, so we're back home, then it would have been nice if the light could go on, but it somehow doesn't want to, right?
No.
But we will see it right here. So
Yeah.
let's say our light should automatically send a command to it, should be turned on. And we could have our house telling us how many visitors we've actually missed while we were away. So for this, we could introduce a rule variable here, which is a number, call it counter, start with 0. And every time that we missed somebody, let's have the counter increase by 1. And now in here, we can just say, you have missed counter visitors. Okay, and another cool feature that I simply have to show is the creation of timers, which is very, very powerful functionality. So actually for a timer, you can now use a Joda time expression here, saying now in 10 seconds, you should do something. And yeah, this something you can define in a closure right in the code here. So with that syntax, you can now really put any kind of code that should be executed in 10 seconds time. To do an easy example, let's simply have the light switched off again. But you could do anything you like. And the good thing is it's really not a static timer, and that will happen in 10 seconds time, but you really get a handle back for this timer, which you can reschedule, which you can cancel by another rule if some other event occurs, and so on. So it's really, really a very flexible functionality. Good. So we are away. We are away. Come on. And we have many visitors.
You have missed 4 visitors.
And we see the light has switched on. And after 10 seconds, it should automatically go off again. Right there we go.
Oh,
and
it
now
switches.
It switched. Woo! It switches. Oh, wonderful. So finally, towards the end, it works.
Perfect.
Wonderful. What a day.
What a day, yeah.
Okay, so now I hope you're really looking forward to playing around with that kind of stuff. And actually, to start playing around, we have a demo server available, which I'll briefly want to show you with the camera as well. Check. Let's see if that now works. So the demo server, oh wait, the QR code wasn't there long enough for you. I could actually try that out. So it's available at demo.openHAB.org, and it resembles more or less a whole house that is set up here. So you can navigate through floors. And now if somebody is already in the bathroom, please switch on the light or off. Ah, yeah, you see, somebody switched. It wasn't me. But I can do it as well. No, I can't. Yes, I can. Okay, so it's really a demo setup with the files that you get also from the homepage, where you see you can do really more advanced things here. Like, for example, also charting then minimum maximum temperature chart for the last 24 hours. You have possibility to group items together here and have, for example, show directly in consolidated way how many windows are open currently. You can then drill down to get the single windows listed and stuff like that. And the nice thing is the sitemap setup you only do once. You can now also access the same setup with a native Android application here in Android UI guidelines style. And you have all the stuff available in here as well.
Or the iOS client as well. They are free of charge.
Yeah, yeah. Whoever has an iPhone can use that as well. So you have different kinds of selection buttons here and many things, sliders going on. You even can embed video stream. So if your webcam is actually a video stream, you can embed other web pages. If you have devices that just display their stuff on a web page, you can also include that in there. So really quite powerful things that you can do with that. Okay. Let's turn that off again. That off again. So what's coming up next for openHAB? As Thomas mentioned already, many of the bindings that we listed will actually come with the next version that is scheduled in about a month from now. Also, new persistent services. We will have a new text-to-speech engine as another option, and many bug fixes, enhancements, and things we did since the last release. After that, we're also planning further improvements on the REST API to allow, for example, directly persisted data to be available to JavaScript clients to do nice dynamic charts and things like that. And also to have notifications available through the REST API, so user interfaces could show you a kind of event log as well and things like that. So many ideas all around, and quite a lot things going on.
Yes, okay. Finally, I'd like to mention that we are constantly moving towards our main goal of world domination, as you already see. Okay, we have our community is very active in the moment. We have 15 active contributors in the moment, around 50 open clones hosted on Google Code, and more than 500 installations from are there in place. These are indication of a very vibrant openHAB community in the moment. And what we do, or what we try to do in the near future to support this community more than now is to support some how-tos. It's very long on my no. Oh, okay. It's
just playing.
It's on my to-do list. Topmost of it is to write some how-tos to create new bindings and to create new persistent services. Probably there will be Maven archetypes to to reduce the ramp-up time for new contributors as well. We hope there will be many, many new features for hardware that we haven't heard about that, and many, many new eyes that are very cool and smart. Probably the MGWT UI, Daniel, Katharina. Would be nice to have that in place. We will see what the future brings. For now, I would like to say thank you very much for your attendance. Hope you enjoyed the talk as we did, although there are some things that aren't working directly, but anyhow. And hope to welcome you as openHAB committer in the near future.
Yeah. Thanks from my side as well. So the screen says we have 1 minute left. So if there's some urgent question, go right away. Otherwise, you'll find us all around the conference here. And yeah,
thank you.
Happy to talk to you.